So this is 83. Title is Isosceles Trapezoid. So yesterday we talked about trapezoids, just regular trapezoids. And what was a trapezoid again? Yeah, Taylor? Good. It has one pair of parallel sides. So a parallelogram has two pair of parallel sides. Trapezoid has one pair of parallel sides. So things that were true about trapezoids were consecutive angles added up to 180. The median was the two bases divided by 2. So those were some facts that were true about regular old trapezoids, all trapezoids. Now today, we're going to have an isosceles trapezoid, and an isosceles trapezoid is a trapezoid, obviously, that has congruent legs. An isosceles trapezoid is a trapezoid that has congruent legs. So that would look like this. First of all, it's got to be a trapezoid, so these two sides are parallel. And then what's different about an isosceles trapezoid is that this side is congruent to that side. Those two legs are congruent. So if you have an isosceles triangle, two of the sides are the same length. And if you have an isosceles trapezoid, then two of the sides are the same length. On a regular trapezoid, maybe this is longer than this. All right, so some things that are true about isosceles trapezoids. Well, first of all, these two angles add up to 180, just like on regular trapezoids. And the median is this plus this divided by 2, just like on regular trapezoids. So that's the stuff we learned yesterday. It still applies to this trapezoid, because this is a trapezoid. And that stuff from yesterday applies to all trapezoids. But there are a few things that are special about isosceles trapezoids. One thing is that the diagonals are congruent. This is not true on every trapezoid. It's only true on isosceles trapezoids. So if you drew in this line, that's the diagonal, right? And then you drew in that line, that's the other diagonal. That length equals this length. The diagonals are congruent. Now there's another figure that we had this week where the diagonals are congruent. Anybody remember what that is? Yeah. Not on a rhombus. On a rhombus, no, you're fine. On a rhombus, the diagonals are perpendicular, but they're not necessarily congruent. On any rectangle, actually, the diagonals are congruent. So it was true on a square, but it's true on any rectangle. Okay, so the diagonals are congruent on an isosceles trapezoid, meaning that length equals that length. Okay, something else that's true on an isosceles trapezoid is these two angles are equal to each other. That's not true on a regular old trapezoid. But on an isosceles trapezoid, those two are equal to each other. And also, these two are equal to each other. That's true on an isosceles trapezoid, but not on every trapezoid. And then it is also true that these add up to 180. But that's true on any trapezoid, not just isosceles trapezoids. All right, that's it for the note card. Thank you for listening. Keep yourself organized. Note cards. Title today is Geometry 6.5. So there's a picture here of a trapezoid. It's just drawn for you. Is this an isosceles trapezoid? Yeah, it is, because these pieces are all equal to each other, so this side is equal to that side. So this is a special trapezoid. Yesterday we just had run-of-the-mill trapezoids. Today we have an isosceles trapezoid. Yeah.
Is this connected to a question or is that a question?
This is connected to several questions.
Okay.
Yeah. So, but you don't need to draw it.
Okay.
We're gonna all look at it and then try to do a few questions. So I was just asking something out loud about whether it was isosceles, and now we're on number 1. Yeah, sometimes these questions just come to me, and they're not on the paper. So, yeah, I see how that was confusing. I was asking if it was isosceles trapezoid. You don't have to write that down. So MA is 34, they tell us in number 1. So they measured from M to A, and it's 34 inches. And then HT is 20. So they measured from H to T, and that's 20 inches. And they want us to find CD. They want to know how far it is from C to D. Yes? Yes, you're close. How'd you get there? Or you are correct. Sorry, you were ahead of me. How'd you get that? Good. So this is called the median, remember? And to get the length of it, you take the two bases and add them up and divide by 2. Does this formula work on every trapezoid? Or does it just work on this trapezoid because it's isosceles? Does this work on every trapezoid? Yeah, it does. It was on yesterday's note card. So it applies to all trapezoids. So it does apply to this trapezoid, which is an isosceles trapezoid. But I don't want you to start thinking that you can only do this on isosceles trapezoid. Okay, so 34 plus 20 is 54. And then divided by 2 is 27. So Emma was correct. Yep. All right, so now for number 2, they told us that HT is 17.6, and they also told us that CD is 28.6. So I guess now we remeasure, we forget all these numbers from number 1, and now this is 17.6, and this is 28.6. So 17.6 here, 28.6 for the median. And they want us to find this, MA. So I'm going to put an X there, because we don't know what that is anymore. So what should I do? Yeah. You still add them up together and divide by 2. The key is, what is the them?
HT plus 17.6 plus 1.6
Okay, now I was worried about that because that's not the right them. You don't add 17.6 and 28.6. Yeah. You add the two bases. Now, Charlie's exactly right, though. It's awkward to add the two bases because we don't know this base, right? But you still add the two bases and divide by 2. So we're going to take 17.6 plus x and divide by 2. So you're exactly right. You add the two bases. We don't know the base, but that's okay. We can still write it down. Is everybody okay with that 17.6 plus x divided by 2? It is awkward. Okay, now after we do that, what should that come out to? Yeah, 28.6, right? Because they gave us the median this time. They gave us the answer this time. So this formula here is the same as this formula over here. It just looks awkward because there's an x in it, but it's still the same idea. Base 1 plus base 2 divided by 2 equals median. All right, now how do we deal with this? Well, this is dividing by 2, right? How do you get rid of divided by 2? Multiply by 2. Good. So I'm going to times by 2 on this side. But if I times by 2 on that side, I also need to times by 2 on this side, because that's the way equations work, right? Whatever you do on the left side, you also got to do on the right side. Bless you. So then the timesing by 2 is going to cross out the dividing by 2. .6 times 2 is 57.2. And now how can I solve for x? Yeah.
This is just subtracting 17.6 to both sides.
Awesome. So you get 49.6, I think. Yes. Oh, thank you very much. Appreciate it. Trying to do things in my head. It's a little dangerous on a Wednesday sometimes. Or maybe I'm just trying to keep you awake. Who knows? Anyway, it's 39.6. All right, you can skip number 3. Never do number 3. So sometimes I skip around and I want you to go back and do the ones I skipped. Don't do number 3. And number 4 says the measure of angle TAM is 63. So over here in our picture, T to A to M is 63. And then they want to know what is the measure of angle HMA. So HMA is, that's this angle here. So how big is it? Is this angle 63? How big is that angle? Yes. 63. Good. Now, does this happen on every trapezoid? Or is this something special that happens on isosceles trapezoids? Where these would both be the same. These would both be 63. Does this just happen on isosceles trapezoids, or does it happen on every trapezoid? Just happens on isosceles trapezoids. Okay? This formula here works on every trapezoid. But this, where the base angles are equal to each other, just happens on isosceles trapezoids. Okay, number 5 says that MT is 19. So let me erase some of this extra stuff over here. They're saying from M to T is 19. All right, and then it wants to know how far from A to H. So, yes, 19 also. Awesome. Does this happen on any trapezoid or where the diagonals are congruent, or does it just happen on isosceles trapezoids? Just happens on isosceles trapezoid. So number 4 and number 5 were specialized things that happen on isosceles trapezoids. But number 1 and number 2 happen on every trapezoid. The median is the average of the bases. All right, the next question is number 19, and this is a true-false question. It says a rhombus is a square. So I'm sorry to make this an English class, just briefly, but what is the subject of this sentence? Yes.
Isn't it rhombus?
Yes, the subject of the sentence is rhombus. Rhombus is the focus. All right, so everything we talk about here needs to be about rhombuses. So I'm going to draw a rhombus. Why is this a rhombus? Yes.
Is it because they have like four sides?
4 congruent sides. Awesome. A rhombus is something, a 4-sided figure that has 4 congruent sides. So this is a rhombus because it has 4 congruent sides. Okay, this rhombus that I drew, is it a square? Yes, it is, because it has 4 right angles as well, right? So this rhombus is a square. So if I just look at this picture, I would start to think that this statement was true, right? A rhombus is a square. Here's a rhombus, it's a square. All right, but is it possible to draw a different picture of a rhombus that isn't a square? Yeah, it is.
Isn't it just like making like an actual rhombus?
Well, I don't like the term actual rhombus because this is an actual rhombus. But what you mean is
Like the stereotypical.
the stereotypical rhombus. I'm with you there, yes. Okay, so here's another rhombus. I don't know that I drew this perfectly, but here's another rhombus that has 4 equal sides. That's why it's a rhombus. Is this rhombus a square? Clearly not, right? Okay, so here's a rhombus that is a square, and here's a rhombus that's not a square. So if someone says a rhombus is a square, you could say, yeah, sometimes. But we don't have that as an option for an answer this time. So is it true or false that a rhombus is a square? It's false because in order to be true, it has to be true all the time. So it is true sometimes, but it's not true all the time. So this is a false statement. So when you're doing true-false questions, in order to be true, it has to be true no matter what. It can't just sometimes be true. All right, now we're going to go back to number 14. Number 14 says a square is a rectangle. So I'm going to draw a square because that's the subject of the sentence this time. Is this square a rectangle? Yes, it is. Why is it a rectangle? Because it has 4 right angles. To be a rectangle, you got to have 4 right angles. So this square is a rectangle because it has 4 right angles. But we do have to be careful because over here we had a rhombus that was a square, and we had then a different picture. So here's a square that is a rectangle. Is it possible to draw a different picture of a square that's not a rectangle? No, it's not. Okay, so that means that this is a true statement. A square is always a rectangle. So that's true.